Hello and welcome to Logic Gates lesson 3. So today you're going to apply your knowledge of logic gates to statements and create a circuit. So what's going to happen in today's lesson is I'm going to go through each of the logic gates again so you remember the rules, and I'm going to discuss the use of the statements and how you can apply a circuit from them, as well as putting some context into logic gates and discussing where they're used. Okay. So the success criteria is you are to recognise and use the standard symbols used to represent the logic gate. Now, being as that you've already had 2 lessons on logic gates, you really should already be on that bronze criteria right there. Then you're going to apply your knowledge to constructing the circuits and forming truth tables. So we did this over the last couple of lessons. So you may be unconfidently sitting on silver, okay, but hopefully we're going to make you confident and put you onto gold, where you apply your knowledge and skills to exam questions. So I'll be going through a couple of exam questions this lesson. So you're going to see how I do it, and then maybe you may want to do your own thing. Maybe you can see a simpler way to do it and you'll be able to figure it out yourselves, which will be fine, or you can just follow the way that I've done it. So it may be a good idea right now to have a pen and paper sitting in front of you. Okay, right. Now, logic gates. So we're going to take a look at these. Now, what I'm going to do is I'm just going to pop this onto the whiteboard and going to draw the logic gates myself. And basically, so the first gate you should remember is the NOT gate. Now, hopefully you remember the NOT gate because it kind of looks like, to me, like, sorry, not very good at drawing with this graphics tab right here. So, oh, there we are. So to me, it looks like, this looks terrible. It looks like a pineapple with a cherry or something at the end. And you should know as well that it has, so 1 input and 1 output. Sorry, bear with me with this. I'm using my graphics tablet and I'm not very good with it. So 1 input and 1 output. So if the input is number 1, what is the output? Hopefully you said 0. So this logic gate should basically, you should have a lot in common with, because it does the exact opposite of what it's supposed to do. So if the input is 1, it'll be 0. So it should remind you of yourself, where you do the exact opposite of what your parents, your teachers say. So that is the first gate. So that's the NOT gate. So the output is always the opposite to the input. Okay, so that's the first logic gate. Now we have another 6 to go, another 5 to go through. So let's take a look at the other ones. So just erase all of this here. And so I'll go back onto the draw tool. There we are. And the next logic gate is the AND logic gate. Now, if you remember, when I discussed this with you last lesson, it's basically a big D for AND, okay? So looks like this. And yep, again, I've done a terrible job. Sorry, I'm so sorry. I'll just scrub that out because I'm not happy with that really. So hopefully I might be able to do it a little bit better. Okay, so I've had this graphics tab for about 6 months and I've never used it. Here we go. And so here we are. It's a big D, okay? And basically this has 2 inputs, okay? So 2 inputs and 1 output. Okay, now the AND gate, the inputs have to be a pair, basically, if we remember. So if the input is 0 here, and then the input is 0 here, then the output here would be 0, okay? But if we was to change this, okay, to an input, if you remember, of 1, the output will still be 0, okay? Because it needs 2 inputs to be the same for the output to be, well, both inputs have to be positive, okay? So both inputs have to be positive basically for the output to be positive, okay? So that's the only way that you will get a positive input is if both, a positive output if both inputs are positive, okay? So if we remember that. So that's 2 down. Now, so I hope you wrote that rule down for each of your gates, or you looked at your notes from last lesson and maybe added to them, which would be absolutely fine as well. So the next gate, so the next gate that we're going to look at is, I think, the OR gates. Okay, now the OR gates, I don't know, maybe you would argue that it's the most useful gate, maybe, okay, not sure. And basically the OR gate looks a little bit like a spaceship, if you remember. Okay, so so here I'm drawing the OR gate, and looks like this one's going better, but I really don't want to speak too soon. Okay, so oops, yep, I shouldn't have spoke too soon. There we go. So there's my little OR gate there that don't look very good. Okay, so it's got one output, as we know, and it's got 2 inputs. All right, so now with the OR gate, basically it's a little bit more flexible, okay, because if it's similar to the AND, if both of these inputs here are negative, then the output is going to be negative. All right, but if we have one input that's positive, okay, so one input is positive here, then the output will be positive, okay? So there's always that rule, all right? So the OR gate is basically either or. If one input is positive, the output will be positive. Both inputs are negative, then the output will be negative. And if the both inputs are positive, the output will be positive. Okay, so this is a little bit more of a flexible gate. So now they're the most 3 simple construction gates here. So now we're going to go into the other ones that have a more varied set of rules. Okay, so you might want to write these down, ready for your exam questions. So I'm just going to get rid of these little dots here. Right, now, so next one we're going to look at is the NAND gate. Okay, so it's kind of, I think you basically would say it's not AND. Okay, so NAND, not AND. So it's just like the gate, you know, you are familiar with this. So you've got the D here, the big D, okay, and then at the end we've got a little circle to represent the NAND, okay. So right, now here is the output, and it has 2 inputs, all right. So with our 2 inputs, now the rules here vary slightly, okay. So now what this does is, because it's not AND, so as you know, the NOT gate will do the exact opposite. And it's similar here with the NAND, okay? So if I was to put both of these as negative, then the output will be positive, okay? So I suppose that's relating from the NOT, all right? And then, so I'm just going to change my inputs and outputs here. So if I had, for example, so this is where we've got the AND bit, but again, it kind of does the opposite. So if we had this as 0 and this as 1, what will be the output? Now, considering obviously that, like I said, this is a NAND gate, so it's got a NOT, all right? So it does the opposite of the AND. And basically the output would be positive on this one here. So this is going to be positive, all right, because it's not, so it does the opposite, all right. Now, so that's basically the NAND gate. Right, now we're going to look at the NOR gate, which is the NOT OR, okay, so NOT OR. So this is the NOR gate. Right, so you're just going to scrub these out for you there. And for our NOR gate, okay, so again, it looks like a spaceship. Okay, so there we are. There's my gates are not going very well here, sorry. There we go. So as is my kind of not a very nice NOR gate. Apologies. All right. Now, as you know, 2 inputs, 1 output. Okay. So now this one's, again, this is the NOT, so it does the opposite. So what would be the output on this if both the inputs are negative? Okay, so obviously the output is going to be positive. All right, positive. All right, and again, it's the NOT. So what it will do here is if I was to change one of these, okay, so if I was to change this here to 1, okay, so then the outcome would be, so I've got 1, 0, so it does the opposite, and it's going to be 0 because it does the opposite of the OR gate, but it's got the NOT. Okay, so it's, so where the NOR gate, sorry, the OR gate, not the NOR gate, the OR gate, if one of those inputs, so if that was 1, 0, which it is, then as you know, the output would be positive, but this is not. So it does the opposite of what the OR gate would do, okay? Now, so that's, oh, sorry, there's one more, the XOR gates, the exclusive OR gate. All right, so I'm going to look at this one, the exclusive OR gate. So I just scrub these out. Oh, this is being a pain, it really is. There we go. Right, now, so final gate we're going to look at that is in, it is in the, well, it is in the syllabus, it's in the book, so let's take a look at it. Right, and this is the exclusive OR gate. Right, so the exclusive OR gate, so looks like the OR gate, as you know, around here and here. Oh, that looks a bit better. Maybe I'm getting slightly better at this. I don't want to speak too soon. And then it's got a line right here. Okay, 2 inputs. Right, I just started getting used to this. And 1 output. Right, so here we go. Now, so this one would be, so if all the inputs are negative, the output is negative. Okay, all inputs negative, output is negative. Now, I suppose all outputs, all inputs that are positive will be positive. Okay, so what this does now is similar, really. Well, no, sorry, I apologise. Just remembered. No, so all outputs, all inputs that are negative, the output is negative. But if all inputs are positive, output is negative. Okay, so that's the difference right there. Then, if I was to change one of these inputs here to 0, which I'm going to do now, so I'm going to change this here to 0, then the output is going to be positive. Okay, so most of the time, all the inputs are positive, with the exception of fully negative and fully positive. Okay, right, so that's all the gates there. Right, so hopefully you've taken notes on those, and just going to clear that screen, so I'm going to clear all my drawings. Oh, why don't I just use that earlier? It would have been a lot easier. Okay, and I'm going to share my screen for you again. Don't know why it stopped sharing that one. And now we're going to go through a couple of things. So, right, now I've got some examples here for you, okay, of where the gates are used, okay? So now the gates are used in most electrical, so I'm just going to, I've noted some things down so I don't forget what I'm telling you. So most of our examples are electrical, as we know, so they're used in smartphones, they're used in watches. So this is something I briefly went through with you last time, okay? So this is a motion detector, Right, so what this does is this is actually like a security light. So, so I'm just going to get my annotation tools up. Okay, so I want to annotate. I'm just going to simply free draw, I think. Right, so here's a security light, which can be placed, well, they can be placed anywhere, front of houses, mostly back gardens. So this is a security light here. Now, what this detects is this will detect if, okay, two things, all right? So it's not going to come on during the day, all right, because it's a light that's used at night. So the two things that it detects is if there is darkness. Oops. Oh God, that looks terrible. I'm sorry. Clear all my drawings. There we go. I think I'll use the text tool actually for this. So just put a circle back around that. There we go. Right. So firstly, it detects if there's darkness, okay, and if there is motion, all right? So if the light, so if it detects, the sensor detects the darkness, so if the sensor detects that there's no daylight, the light will not come on, okay? So if there is daylight and there is motion, the light will not come on because it needs those two things. Okay, so what logic gate do you think this will use? Okay, good. Hopefully you've said to me, you said on your screens that it will use, or thought in your head that it will use the AND gate. Okay, so if this was to use the AND gate, then what will happen is, so I'm going to draw my AND gate here. And it's going to detect, so for example, I'm going to put D here, so, and I'm going to put M here. So now the output will be, is it dark? If it's dark, then it should be 1. Is there motion? No, there's no motion. So then the outcome will be 0. But then someone comes walking to, could be a friend, could be a burglar, could be anybody. So it could even be a fox, for example. So then if it detects motion, then the outcome is going to be 1, okay? So that would definitely use an AND gate because the sensors have got to detect two things for the light to come live, okay? Right, so that's an example with a security light there. So hopefully it's made things clearer of where the AND gate would be, where it would be used. Okay, so next thing, here's another example, okay? Another example we're going to use is a burglar alarm, all right? So now when someone has a burglar alarm, generally the burglar alarm is fitted on the front of their house, okay? For various reasons, or it could be like, for example, here, they may, for example, have the burglar alarm sitting here, which might have a light and it will have a speaker, okay? So let's just work on one output, and the one output is going to be the sound of the alarm, okay? Now, what will happen is they will have a number of sensors around the house, okay? And generally they'll put the sensors in most likely places that the burglar is going to break in or where the burglar is going to go, okay? So let's just say, for example, here, okay, so this, let's just say, for example, here, there's a sensor here in the conservatory. And imagine this is going to be a bedroom. So there'll be a sensor here in a bedroom. Okay. So now, so let's put this as our input. So our input would be B for bedroom and C for conservatory. All right. Now, what's going to happen there is that what we don't want is it's not going to work with an AND gate. Okay. Because we don't want, say, the burglar to break in. They're in the house, they're already there, but the alarm hasn't sounded because they haven't gone on into the bedroom yet, okay? So what we want is we want to make sure that no matter where the burglar breaks in, no matter what sensor is triggered, then something's going to happen, okay? So like the sensor will pick it up. So here would probably be an OR gate, okay? So here we would use an OR gate. So there's the bedroom and there's the conservatory input. There's the sensors. Okay, so from there, okay, what we want as well is we don't want, obviously, we want to make sure that the alarm is only on at certain times, like for example, when you're on holiday or when you're going out. Because when you're home, there's going to be movement around your house all the time, okay? So the next thing that we need to make sure of is that the alarm is on, okay? So we'd probably have another input, okay? And the other input would be alarm. So is the alarm on? Now, obviously, we don't want to make sure whether the alarm's on or not is going to go off, okay? So I think the best thing to do would be to connect this to an AND gate. So here, I'm going to put an AND gate, okay? And in here is where the alarm's on. So I would join these right here to the AND gate, and then the output would be the alarm. So if we look at these inputs here, right, the sensors may be on all the time. So is bedroom sensor on? Yes. Is the conservatory sensor on? Yes. Is the alarm on? No, because there's people home. So we don't want the alarm on, okay? So then the whole point here is that might be a 1, okay? Because there's people in the house, so both those sensors detected something, but this is a 0. So then, you know, the input that's going here is going to be a 0. So 1 and 0 would be 0. The alarm's not going to go off, so it's functioning. But then, if we was to change this, okay, to think of another scenario here, and that would be that the Smith family have gone to the beach for the day, okay? Nobody's home. So they've put the burglar alarm on, okay? So the burglar alarm is on. Nobody's home, okay? Oh, but somebody's trying to break in, and they've broken in through the conservatory. So the sensor in the conservatory has picked them up. Bedroom hasn't, they haven't got to the bedroom yet. So now the output of this OR gate is 1. And the alarm's on, so this is 1. Therefore, the burglar alarm will sound. Okay? Right, so that's that done. Now, so hopefully that's put a little bit of context into how the logic gates work. Now, last example I'm going to give you is a very simple one. So you're probably wondering, well, where on earth would the NOT gates ever be used? I can't think where they'd ever be used, okay? Well, they're actually used in central heating systems. So in cold countries such as the UK, it is freezing in the winter. It's very, very cold, okay? And it's not uncommon for people to have radiators underneath their windows, for example, because obviously that's where the cold air is going to come through. So, so most people have got, you know, boiler systems that work with gas, and the radiators here which fill up with hot water and radiate heat, okay? And they're controlled by a thermostat here. So what you can do is you can actually set your thermostat, okay, to be at, say something like 18 degrees. So, oops, I'm going to put this onto drawing tool here. So, like I said, so for example, if, you know, it goes above 18 degrees, you want the heating to come on. If it goes below 18 degrees, you don't want the heating to come on, okay? So this is where the NOT gate would come in. So I'm just going to draw my NOT gate here. Oops, and there we go, the NOT, there we are, and it's always got 1 input and 1 output. So, for example, here's a question. Is the room temperature above 18 degrees? Yes. We don't want the heating on because, you know, the room temperature is good enough, okay? So, is the room temperature above 18 degrees. No, it's 12 degrees, which, you know, isn't pleasant, okay? So in that case, we want heating to come on to warm the house up. So that's where a NOT gate would be used. A very, very simple example right there. Okay, so hopefully that's made things a little bit clearer for you. Just use clearer drawings, actually. There we go. Now, moving on. So we're going to take a look at exam questions now. Okay, so our exam question here wants us to do two things. So it wants us to look at the logic circuit. So here you can see there's an AND gate, there's a NOT gate, there's an exclusive OR gate, and there's an OR gate here, okay? So we're looking at this logic circuit. Now, obviously, we don't know what this logic circuit's for, but it doesn't matter, okay? Because what we're going to look at is how we read into these gates, how we complete the truth table, and how we write a logic statement to match the given circuit, okay? So that's what we're going to look at. Now, so what we're going to do is we need to take a look at these logic circuits. So if you remember, I actually gave you before like a protocol to go by, and that was NOT and OR, NOT and OR, okay? And then there's brackets. So we look at this statement here, okay? I'm going to put I think I'll put the text tool on this time. Annotate text, okay? So we're going to write this logic statement now. So now, obviously, the output is X, right? So let's take a look at the output of X, okay? So now X really should probably equal to 1, okay, as an output. So if X did equal 1, for example, and then we go down, open up brackets. So we'll go down in terms of looking at each input. So you go A, B, C, and how it's split up, okay? So now A, as we can see, goes into the exclusive OR gate, all right? So A is 1, okay? So if A is 1, and that goes into, so if A is 1, is going into the exclusive OR gate. Oops. Now, so if A is 1, it goes into the exclusive OR gate, and then from there, it's going to go into OR, okay? So, no, I apologise, it's got 2 inputs. What am I doing? So, A is going into the exclusive OR gate, and from there, the second input is C. Okay, or if C is 1. There we go. So we got that. Now we're going to look at B. Okay, so now B, as you can see here, goes into, so all of these finish with OR. So I'm just going to put here OR. I think that'd be the best thing to do, because we've got A into the exclusive OR gate, and then at the end they all go into this OR gate here. So we would split it up with OR. Okay, so OR, so if B is 1, okay, and now the B goes straight into a NAND gate, as you can see. So we've got a NAND gate. So you just follow on this way. Make this a bit bigger. Okay, so we go straight into the NAND. And then, as you can see, the NAND here has got its inputs of C, okay? So, input is C, okay? But also the C, input C goes into the NOT, okay? So we've got, oh, sorry, is NOT. Okay, 1, right. So that's that one then. Now we're going to split this up again with another, no, we're not actually, because I think I've done that. We've got all the inputs, haven't we? Yes, we do. Yeah, we do have all the inputs. So that's how we got in there. So if we take a look at this, so let's just go over this again. So if A goes into the exclusive OR gate. And then we've got another input with A, which is C. Okay, so if both of those are 1. So that's how those two are joined. Then we've got an OR, because as I said, they're split up at the end with an OR. Okay, because all of them go into the OR. That's where they lead to. So if B, goes into the NAND, then the NAND has basically gone to the junction here through to C, where C is joined with a NOT. And they all join up at the end with an OR. Okay, so that's how you can write the statements. I mean, another way you can simplify this really is, so I'm just going to put this up here actually. No, it's only, oh, here we are. Another way we can split this up really is, rather than thinking about the 1s and the 0s, so if you just go X equals, okay, and you can just look at the junctions, say A is joined with X or C, okay, because A goes into the XOR, C as well is joined by the XOR, because you can see C comes off at a junction here, okay. Then why is it doing that? Oh, okay, right, I'll just let it have its way then. Then obviously it's split with an OR at the end, and then you can say B goes into a NAND. Obviously put your brackets in and close your brackets as well, sorry. Close, forgot to close the bracket here. Oh, it keeps disappearing. Oh, here we are. Oh, that's strange. Okay, it's not letting me do it. Okay, I suppose when I click off it, it won't. So B goes into a NAND gate, and then it's joined by a NOT gate within C. Okay, so that's a way you can simplify it there. Right, next thing we're going to do, okay, is, now I'm hoping you are confident with this, but I'll go through it anyway. You can see here for the second part of the question, now this is a really easy 4 marks, okay, a really simple 4 marks. I'm just going to put this on the draw and draw my terrible ones here. Okay, right, now what I do is I simply follow, and for me it is a fail-safe way. Right, so what you can do is annotate the tables here. So I'm going to go 0, 0, 0, because I'm going by this one here. Now, so if A is 0, and this is an exclusive OR gate, so this input is 0, okay? And then we've got B, where the input is 0 here. Then we've got C, where the input is 0 here, and obviously up here as well, because it's joined by the junction. So now with a NOT gate, we know the opposite happens. So we know that's going to be a 1 there. So therefore, there's a 1 there. Okay. So now we've got our NAND gate. Right, so we've got to look at the rules. Now this is where you start to look at the rules of the gate. So you can refer back to your notes that you made earlier. So the exclusive OR gate has got 0 and 0 together. So that will still be a negative. And then it's going to finish up along here where there's a negative. So now we've got our NAND gate, okay, where you've got a negative and a positive, a 0 and a 1. Now for the NAND gate, a 0 and a 1 will make a positive, okay? So that's a positive there, where it's in the OR gate. So it finishes up at the OR gate here. And now we know the OR gate doesn't mind, so that will be a 1. So then here, you will enter this as a 1. And then you do the same for the rest, okay? So what you can do right now is you can pause this video and you can practice this yourself and then check the answers with me on the next slide. Welcome back. Okay, so I'm just going to clear this, clear all drawings. I'm going to put this back on mouse and I'm going to move on. Okay, so let's move on. So we're going to check the answers. So here are the answers. So you can see here that I came up earlier with the statement, and you can see I've got the statement here and a simplified statement, but they give you 1 mark per bullet point. So if you recognised A and C go into the exclusive or, then they're split with an or, and then they go into B, and not C, you will get 3 marks, I believe. Okay, so if I move my camera here out the way, my screen here, there we go, we've got 3 marks, all right? And then here you get 4 marks. So hopefully you've given this a go and you practiced it yourself, okay? So you get 4 marks for 8 correct inputs. So if all 8 of them are correct, sorry, outputs, not inputs, and then 3 marks for 6, and then you can see it goes down and goes down, okay? Right, if you want to pause this video now and check your work, do so. Okay, moving on. So this is the second exam question. Right, now, please do remember the order of rank that I've given you previously, where these are the 3 main construction gates. And this is the order they go in, not, and, or, when constructing a circuit, okay? So not, and, or. Now, sorry, my notes, I'll just make sure I'm not forgetting anything. Yeah, not and or. And then the exception to the rule, obviously, is brackets. So brackets come first. But sometimes it doesn't make a difference, okay, sometimes. But please do go by that. When constructing circuits, you do your not, you do your and you do your or, and then your brackets always come first, okay? So always go by the brackets first, a bit like bigmus in maths. Right, so I'm going to go through an exam question with you. And this is the exam question that we're going to go through, where we're going to construct a circuit, okay? So you can see we've got like a bit of a complicated circuit there, but don't be frightened, okay, by what it is. So it says, draw a logic circuit to match the given logic statement. Each logic gate used must have a maximum of 2 inputs. Do not attempt to simplify the logic statement, okay? So don't even waste your time trying to simplify it, all right? Just go by the brackets, okay? And go by the logical order, okay? So we've got our A, B, and we've got our C. Right, now, so how do we tackle this? Okay, well, how do we tackle this is brackets first, not and or, okay? So you can see that there is B has got the not that goes into the nor. C is, so B has a not and then there's a nor, all right? So what I'm going to do firstly is I'm going to construct that not gate. So along here, I'm going to go over here and I'm going to put in my not gate. So I'm not going to put it right up against here, because if you've got any other junctions that are going in, then it's going to be a bit of a, okay. Right, now the way I do this might not be the best way. Maybe you guys have got some better ideas, okay? Because sometimes I do attempt to do things haphazardly, okay? So, right, oops, actually, so I'm going to put this on annotate because I think it thinks I'm right-clicking. So, annotate, draw, I'll just do it in red so it's the same, okay? So here we go. Right, so there's my, and then the not is B, isn't it? Okay, let's get rid of that menu there. Right, so the not is B, yeah, there we go. So, oh, let's see, okay. So this is going to be a little bit annoying. Right, okay. In fact, what I'm going to do, I'm going to move this over. So, end show. No, I discard the ink annotation. Oh, screen, stop screen sharing. Sorry, I apologize. There we go. Right. I'm going to move this over here. All right, there we go. So there we go. Right, now, sorry, screen share. There we are. And you're back. Apologise for that. Here we go. All right, let's get back into it. So, here we go. Right, now, let's get back into this. Oh, it's still a problem, isn't it, that menu? Still an issue. So, shrink that down then. Hopefully this will... Okay, right, so we're still sharing the screen, so that's good. Right, so I'm going to annotate this again. Right, okay, back into it. Now, so, right, yes, I said the B was the not, didn't I? So I'm just going to draw my not gate here, very badly. And it's only got one input. There we go. Okay, so there's that one done. Right, so now what I'm going to do is I'm just going to tick that, well, I'm going to cross that out there. Okay, right, and then C is attached to a NOR gate. Okay, so so I go over to C here, and I'm going to draw that because I think that might go in. So what I'm going to do is I'm going to draw my NOR gate here. There's my NOR gate, and that goes into C. Okay, right, there we go. Now, so now it says B1 NOR C is 1. So then we're going to make a junction that goes down here. So now that one is done. Okay, and it looks like it all ends with an OR. So yeah, I'd say it all ends with an OR. So X is going to be on the OR. Well, I'll draw that afterwards. But what I'm going to do now is I'm going to do A. Okay, so we've done, so not and or, all right? So, but the brackets go there. So we can see that over here, A and B is 1. A and B, okay? So I think, yeah, A and B. So, but I would say the and probably goes in the middle here because you've got to think about the order of rank. So A going in there, and then I'm going to make a junction, I think that's correct, here, because it says A and B is 1. There we go. Right, and then that's going to have an output, isn't it? And then that output, so A and B is 1, not and or, so the or is going to go last here as the output. And then I'm going to move that down there. Okay, so now we're getting our construction. So A is also a NOR and C is a 1. Okay, so I might have to change that maybe, but what I'll do first of all is I'll draw my NOR gate. NAND, no, NOR, yes, NOR. Okay, there we go. So we've got our junction in there. Apologise for the line going through, okay. So, and C, so we've got a junction going from C over here, okay? So A and C, because they're both going in, right? So where's that going to go? So that's, that's going to join to the and, hang on, I think I might have made an error there. So I'm going to get rid of that, okay? I mean, if I've made a mistake getting rid of it, it doesn't matter because I can put it back afterwards, can't I? So A, NOR, and C is 1, and then they go into, oops, the and here, but there's still something not right. Okay, so right now I need to join the rest of these junctions up, don't I? So we've got NOR, C, NOR going into OR. Okay, and then So we got, I think I've got a junction wrong. Have I got a junction wrong? Right, so A1 nor, okay, and C going into the nor, going into the and. No, there's my junction that's completely wrong there. No, yes, that is totally wrong. That's completely incorrect. Okay, so A, whoops. Right, so you can see that I'm not perfect. You can see that I can't always get these things completely right the first time round. Okay, so we've got A, nor, and C is 1, and then we've got and. So we've got the B going here into the not, and then yes, and B. Right, so we can have a junction going from B into the and here. Okay, so I think that's joined it all together. Yes, I think that might be, oh, actually, we can probably put another, it might make sense actually to put another and gate in. There's 2 ands. I've missed it out. There's 2 ands. Okay, so we need another and gate. I've been silly and I've missed out the other end. Okay, so that means I've got to reconfigure my, right, so I've got to reconfigure my junctions. Now, so as we can see, A is nor, C is 1, there we go, and, so we're going into an and there. So that's probably right. So, right, in fact, let's start this again. Right, so let's start this again and do this a little bit more logically. Okay, so last attempt, and if I get this one wrong, I'll just show you the mark scheme. But like I said, I'm not perfect, okay? I can't sit there and do this so easily that it looks like I'm the expert. I'm far from it. Right, so let's firstly start with this. Right, so not and or. So in fact, I'm just going to go from the brackets. I'm going to do it in the correct order, not the haphazard way I did it before. Right, A is, right, so we've got a NOR gate. Let's draw the NOR. There we go. Okay. A goes into the NOR, and C can also go into the NOR. Then we've got an AND. Okay, so I've got to draw an AND gate. Okay, right. Now, B is not 1. Okay, so I'm going to draw my NOT gate. There we go. Okay. NOR is C. C as a NOR gate. Okay, so C will have a NOR gate. So let's draw another NOR gate here. And C can go off into that too. Obviously, you draw a junction right here. So you indicate a junction like that. Right, and obviously that's got to have 2 inputs. So now it says B's in that bracket, so I'm going to put B there. Okay, right, now, next one is an OR, okay? So now, so it goes not and or, so I'm going to stick with the OR, goes right at the end here, okay? So that's an OR gate. Sorry, it looks so bad, I accidentally clicked on a bit at the side. Right, now, so we're going to go on to the next bit. So A is 1 and B. So A and B. Right, now, so there's another AND gate. Right, so now we've got to join these 2 AND gates. Okay, so it says, oh, that's where I went wrong. So A is going to have a junction over here. Okay, right, so A's got a junction over there. That's where I went wrong. And B, right, so B is going to have a junction going from here to there. Okay, I got it. And then So these would join here to the other end, and then that's got to have an output there, and that's got to have an output there. Okay, it looks a mess, but it's correct, I believe. Okay, now from there, obviously you have to make sure that your circuit is correct. Okay, it has to be correct, because if it's not correct, and obviously drawn neatly, I mean, I've drawn this on the graphics tab, so it looks a mess. If your circuit isn't correct, the next 4 marks that you're getting are not going to be correct either. Okay, so it's very important that you make sure that your circuit adds up and it works. All right, so then what you do from there is you need to complete the truth table. So, and make sure that you put all your inputs in to make your truth table that I showed you earlier. Right, okay, so I'm just going to move on. So I'm going to have the mouse and clear all, no, actually, right, wait, let me move on. Yes, there we go. So here's my circuit. So I wanted you to see it. And this is what the mark scheme shows. So you can see now that, I know it looks a mess. I'm sorry, I know it's difficult. But if you pause the video, you can check my circuit against the exam boards, which you can see is correct, but it just looks a mess. Okay, and then there's the truth table there. So, right, so now moving on, so you can see how to construct a circuit, okay, and hopefully you've followed the rules like the order of rank like I showed you and how to do it. So the first way that I did it was a bit haphazard. I shouldn't have started that way. I should have followed the brackets, the rules as they are, okay, but the OR, I know, was in the middle, okay, here, but in terms of the order of rank, the OR comes last. So you put your brackets in first and follow the brackets exactly as you see them there, because once I did that, it was much better. Bracket, bracket, join it with the and, bracket, end it with an OR, okay? Now, let's clear the drawings, okay? So, what you're going to do now is, obviously, if you've used your 50 minutes on this video, which we may have done, you can do the exam questions tomorrow. Check Google Classrooms, because I may not have set the exam questions for today's lesson due to the length of the video. Okay. Now, tomorrow, you'll be, next lesson, be completing some exam questions. So I'm going to give you 3 exam questions of constructing logic circuits and completing truth tables. Okay, they're converted to a Word document. So if you wish to use a graphics tablet to complete the exam questions, you can. But also what I've put on there is I've actually got some electronic templates of the logic gates, and you can cut and paste them on there and join them with lines, okay? Or if you wish to complete this on paper, take a photo of it and upload it as an assignment, okay? Right, very best of luck, and I hope today you feel a bit more confident.